Hello everyone, welcome to IGCSE with Optimus. Subscribe to our channel and hit the bell icon to never miss an update on our IGCSE content.
Hello dear students, in today's video we are going to talk about paper 22 from May-June series 2024 for AS level structured questions. You can see first question on the screen. The question says that the list below shows some SI quantities. Underline the quantity that is not an SI base quantity. Now out of the list that they have given, we know that current, length and time are the fundamental quantities or SI base quantities. But charge is not an SI base quantity because charge is calculated as product of current and time. Next question, it says a square solar panel with sides of length 1300 mm is shown in the figure. Light is incident normally on the solar panel. The power of the light incident on the solar panel is 750 watt. Calculate the intensity of the light. The formula for intensity is power per unit area. Now the power incident is 750 watt and for a square panel the area will be side square. Here since the sides are given in millimeter, we will write them as 1300 into 10 raised to minus 3 and the square of it. The answer is 443.8. So we will write it as 440 watt per meter square. The next question, the percentage uncertainty in the incident power is plus minus 3%. The uncertainty in the length of each side is plus minus 5 millimeter. So the percentage uncertainty in the power is given in percentage, whereas the uncertainty for the length is given in absolute uncertainty. Calculate the percentage uncertainty in the intensity of the light. So first we have to convert absolute uncertainty in the length into percentage uncertainty. So it will be 5 divided by 1300 into 100. The answer is 0.38%. Now, while calculating intensity, it was power upon area. So power comes once and area for area length comes twice. So the total percentage uncertainty can be given as 3 plus 0.38 multiplied by 2. The answer is 3.76. So we can write 4%. Next question. The useful power output of the solar panel is 160 watt. Calculate percentage efficiency of the solar panel. The formula for percentage efficiency is output power upon input power into 100. So we can write it as efficiency is equal to output power upon input power into 100. So it is 160 upon 750 into 100. The answer is 21.3. We will write it as 21%. Next question. Another square solar panel is placed so that light of same intensity is incident normally on it. The new panel has shorter sides than the original panel. The new panel has same power output as the original panel. State and explain whether the efficiency of the solar panel is greater than, less than or same as the efficiency of the original panel. Now the new panel is having shorter sides. Due to shorter sides, it will receive less input power. Even though it is receiving less input power, it is giving same output, means it has higher efficiency than the previous panel. So we will write due to shorter sides, Panels have smaller area, they receive less power input. However, as power output is same, they have higher efficiency. We will now go to the second question, question number 2. The question says, a skydiver jumps from an aircraft at time t equal to 0 and falls vertically downward. The variation with t of her velocity v is shown in the figure. Using figure 2.1, state the terminal velocity of the skydiver. Now we know that the terminal velocity is the constant velocity achieved by falling objects when the weight of the object or the downward force is balanced by air resistance, which is upward force. Here, the object achieves constant velocity of this value, which is here, that's 39. So, the answer here for terminal velocity would be 39 meter per second. The next question says, by drawing a suitable line on figure 2.1, determine the acceleration of the skydiver at t equals to 9 seconds. So, we are supposed to calculate the acceleration for t equals to 9. Now, the t equals to 9 comes somewhere here on x-axis. So, we are supposed to find out acceleration for this point. Since this point is a part of a curve, to calculate the acceleration here, we will have to calculate gradient, and for that we will have to draw a tangent to this line. Like this. So, we can consider this point and we can consider this point to calculate the gradient. The coordinates for the first point are 4,30 and coordinates for the second point are 15, 40.5. So, the acceleration is equal to gradient, that will be y2 minus y1 upon x2 minus x1. So, it will be 40.5 minus 30 divided by 15 minus 4. The answer here is 0.95. So, we can write it as 1 meter per second square. The next question, the mass of the skydiver and her equipments is 68 kg. The upthrust on the skydiver is negligible. After reaching terminal velocity, the skydiver opens her parachute at time t1. So, she is opening her parachute at time t1 when her terminal velocity is going on. A total drag force of 1800 Newton acts on the skydiver. The drag force is going to be in upward direction. Determine the magnitude and the direction of the acceleration of the skydiver at time t1. Now, we will first calculate the downward force acting on her. The downward force will be due to her mass, that is mg. It is 667 Newton. We already have the upward force, so we can calculate the net force acting on her. It will be 1800 minus 667 Newton. Now the acceleration is net force upon mass, which is 1133 divided by 68. The answer is 16.7. We can write 17 meter per second square. Since the greater force is in upward direction, the acceleration will also be in upward direction. Now, the next question says the parachute is fully open at time t2. At a later time t3, the skydiver reaches a constant velocity of 5.7 meter per second. Describe and explain the variation with time of the magnitude of her acceleration between T2 to T3. So, the person is achieving second terminal velocity of value 5.7. You can understand the previous terminal velocity was 39 meter per second and now the new terminal velocity is 5.7 meter per second. Why the person achieves lower terminal velocity? Because when the parachute is opened, the drag force will be increasing and her velocity will go on decreasing. But eventually, as the speed of the skydiver decreases, the air resistance also decreases, the drag force decreases, and because of which she achieves lower terminal velocity. So we can write as parachute is opened, drag force decreases speed of the diver. As speed decreases, drag force also decreases. Subsequently, net force and acceleration decreases to 0. Next question, calculate the change in momentum of the skydiver between T1 and time T3. So, the change in momentum is given as m bracket v minus u. The mass of the skydiver and the equipments in total is 68. Her final velocity is 5.7 meter per second and at T1 her terminal velocity was 39. So the change in momentum would be minus 2264. Since they are only asking about change, we will not include sign minus, we can write 2300 Newton seconds. We will go to question number 3 now. Question number 3 says, lightning occurs when charge builds up in the atmosphere, creating a potential difference between the ground and the atmosphere. During a lightning strike, there is an average current of 3.3 into 10 raised to 4 ampere for time of 2.6 into 10 raised to minus 5 seconds. Calculate the charge transferred during the lightning strike. We know the formula for charge. Charge is product of current and time. The current is 3.3 into 10 raised to minus 10 raised to 4 ampere and time is 2.6 into 10 raised to minus 5 seconds. The answer here is 0.86 coulomb. Question B. The potential difference between the ground and the atmosphere is 3 into 10 raised to 7 volt. Calculate average power in gigawatt transferred during the lightning strike. The formula for power is voltage into current. The voltage is 3 into 10 raised to 7 and the current is 3.3 into 10 raised to 4. The answer is 9.9 into 10 raised to 11. They are not asking us the answer in SI unit of power, they are asking us answer in gigawatt. We know that 1 gigawatt is 10 raised to 9 watt. So we can write the same number as 9.9 into 10 raised to 2 gigawatt. So the final answer would be 990 gigawatt. Question C, it says a lightning rod is attached to a tall building to conduct charge safely to the ground. The lightning rod is modeled as a uniform cylindrical copper cable of total length 95 meter that runs from the ground to the top of the building as shown in the figure. The resistance of the lightning rod is 9.6 ohms. The resistivity of copper is 1.7 into 10 raised to minus 8 ohms meter. Determine the radius of the lightning rod. We know the formula for resistivity. Resistivity is given as Ra upon L, where area is area of cross section of the cylinder, that is area of circle. It will be R into pi r square upon L. Now if I want radius, it will be under root of rho multiplied by L divided by R into pi. That will be equal to 1.7 into 10 raised to minus 8 multiplied by length of the conductor, which is given here, that is 95 meter, divided by resistance 9.6 into pi. The answer you will get is 2.3 into 10 raised to minus 4 meter. That's the radius of the wire. Next question. The radius of the copper lightning rod is doubled with no change to its length. State the effect of this change on the resistance of the lightning rod. We know that resistance is inversely proportional to the area, and area is given as pi r square. So if you double the radius of the wire, the resistance is going to be decreasing by factor of 4. Why? Because it is 2r square, so it's going to be 1 divided by 4. So we will say resistance decreases by factor of 4, or you can say by 1/4. Next question. A section of lightning rod of length 0.12 meter is removed for testing. A tensile stress of 1.9 into 10 raised to 6 Pascal is applied as shown in figure. This section of the rod obeys Hooke's law. The Young's modulus of the copper is 1.3 into 10 raised to 11 Pascal. Calculate extension of the section. We know the formula for Young's modulus. It is stress upon strain. So we can write it as FL upon A into small l, where small l is the extension. So L will be equal to F into L upon A into Young's modulus. Since we know that stress is equal to F upon A, we can directly calculate length as stress multiplied by original length upon Young's modulus, because we are already given with the value of tensile stress. The tensile stress will be 1.9 into 10 raised to 6 Pascal multiplied by length of the wire, that is 0.12, divided by Young's modulus, that is 1.3 into 10 raised to 11 Pascals. The answer is 1.75 into 10 raised to minus 6. We can write it as 1.8 into 10 raised to minus 6 meter. Going to the fourth question, question number 4 says that a pinball machine uses a spring to launch a small metal ball of mass 4.5 into 10 raised to minus 2 kilogram up a ramp. So we have got mass here. The spring is compressed by 8 into 10 raised to minus 2 meter. You can consider it as extension, and held in equilibrium as shown in figure 4.1. The compression is, you can say, change in length. So I have marked it by letter X. The ramp is at angle 15 degrees to the horizontal. The spring obeys Hooke's law and has a spring constant of 29 Newton per meter. Calculate elastic potential energy in the compressed spring. We know the formula for elastic potential energy. It is half into Kx square, where K is the spring constant of the given spring. So it will be half into 29 into extension is 8 into 10 raised to minus 2 the whole square. The answer here is 0.093 joules. Question B. The spring is released and it expands quickly back to its original length. Calculate the increase in gravitational potential energy of the ball when the spring returns to its original length. Now note that whenever we talk about gravitational potential energy, we use formula GPE equals to mgh. But note that here height is a vertical height that we are supposed to consider. So if you consider change in length of the spring as 8 into 10 raised to minus 2, that is given over here, and this angle as 15 degrees, this vertical height we need to calculate the change in gravitational potential energy. Okay, so the value of h can be given as 8 into 10 raised to minus 2 multiplied by sine theta. So we can write this as mgh sine theta. The mass of the ball is given as 4.5 into 10 raised to minus 2 kg. G is 9.81 and height will be 8 into 10 raised to minus 2 multiplied by sine 15. Note, why are we taking sine 15 here? Because we want to consider vertical height only for gravitational potential energy. The final answer here is 9.1 into 10 raised to minus 3. Now, next question. The ball leaves the spring when the spring reaches to its original length. Assume that all the elastic potential energy of the spring is transferred to the ball. Calculate the speed of the ball as it leaves the spring. Now note that the initial elastic potential energy of the ball is of the spring is converted into two parts, that is gravitational potential energy gained by the ball, and the remaining energy will be given as kinetic energy to the ball. We already know the value of elastic potential energy, that is 0.093. We know the value of gravitational potential energy, that is 9.1 into 10 raised to minus 3, and that will give us the value of kinetic energy the ball carries. 0.093 minus 9.1 into 10 raised to minus 3 gives us 0.084 joule. So this is the kinetic energy ball is having, and now we know the formula for kinetic energy, half mv square. So v will be under root 2 into kinetic energy, that is 0.084 divided by the mass of the object, that is 4.5 into 10 raised to minus 2. So the final answer you get over here is 1.93. You can write it as 1.9 meter per second. The next question says the ball comes to rest on horizontal trapdoor of negligible mass at distance d from the pivot. A force F acts vertically downward at distance 2 cm from the pivot as shown in figure. The trapdoor is in equilibrium when the F is 1.7 Newton. So this value we are given with, that is 1.7 Newton. Calculate the distance d. Here the second force that we are supposed to consider is the weight of the ball, and weight is given as m into g. To calculate distance d, we will use formula total clockwise moment is equal to total anti-clockwise moment. So the clockwise moment is produced by weight of the ball. It can be given as 4.5 into 10 raised to minus 2 multiplied by 9.8 multiplied by d, and anti-clockwise moment is produced by F, so it will be 1.7 into the distance is 2 centimeter, so we will write 0.02. D will be 0.077. Okay. Next, force F is decreased from 1.7 Newton. State the direction of the resultant moment about the pivot on the trapdoor. Now you can see, as per the conditions given in the above question, the system was in equilibrium. So if the force F decreases from 1.7 Newton, then obviously the anti-clockwise moment is going to be decreasing than clockwise moment, and the object is going to topple clockwise. So the direction of the resultant moment will be clockwise. We will move to the next question, question number 5. It says, state Kirchhoff's second law. Now Kirchhoff's second law says that the algebraic sum of all the EMFs in circuit and the potential difference is equal to 0. So if we go on adding all the potential differences, the addition of all potential differences will be equal to the sum of all the EMFs connected in the circuit. Question B says a battery of electromotive force 9 volt and negligible internal resistance is connected in series with a variable resistor X and a thermistor Y as shown. Figure 5.2 shows the relationship between the temperature and the resistance of the thermistor. Question 1 says the current in the circuit is 1.1 into 10 raised to minus 2 ampere. The potential difference across Y is 4 volt. So, the potential difference across Y is 4 volt. The total potential difference is 9, or you can say EMF is 9. Then the potential difference across X is going to be 5 volt. Question says calculate the resistance of X. To find out the resistance of X, we have to use formula V by I. Now, the voltage across X will be total EMF, that's 9, minus the voltage across Y, that is 4, and we will divide it by current, that's 1.1 into 10 raised to minus 2. The answer is 454, so we can write it as 450 ohms. The temperature of Y is changed to 190 degrees Celsius. The resistance of X remains unchanged. Determine the new potential difference across Y. Now, to find out the new potential difference across Y, we will have to use formula I into R. But for that, we need to understand if the resistance across Y changes, then the total current in the circuit will also change. So the first thing that we have to work out is what will be the value of resistance when the temperature is 190. So when the temperature is 190 degrees Celsius, the value of resistance is 25 ohms for the thermistor. So the value of resistance of Y is 25 and value of resistance of X is 450 as we have calculated. The total resistance of the circuit will be 450 plus 25, that is 475 ohms. Then the total current in the circuit will be total resistance upon total voltage upon total resistance, that is 9 upon 475. The answer is 0.019, and using that we can calculate the new voltage across Y. It will be 0.019 into 25, 0.47 volt. Now, the next question says the resistance of X increased. The temperature of Y remains at 190. By reference to the current in the circuit, state and explain the effect of this change, if any, on the potential difference across Y. Now, they have increased the resistance of X. Subsequently, the total resistance in the circuit is going to be increased because these two devices are in series. If total resistance increases, then the total current in the circuit will decrease. If current decreases, the potential difference across Y will also decrease because V is equal to I into R. So, we can write the overall resistance of circuit increases, because of which current in the circuit decreases. Since V is given as I into R, the voltage across Y will decrease. We will now go to the next question, question number 6. Question says, light of single frequency is incident normally on a diffraction grating. An interference pattern of bright and dark fringes forms on the semicircular screen shown in figure 6.1. Now note that here on the center part we will be seeing a central maxima and we will be seeing the orders of maxima above and below the central maxima. We call this as nth order of maxima. Okay. The question says the light has wavelength of 520 nanometer. The separation of the lines in the grating is 3.8 into 10 raised to minus 6 meter. So we have got wavelength, we have got the distance between the separation, or you can say the grating, that is D. Determine the total number of bright fringes formed on the screen. We know the formula, it is d sin theta equals to n lambda, where n is the order of maxima. So n will be equal to d sin theta upon lambda. D is 3.8 into 10 raised to minus 6. Since the light is falling normally, the angle value will be 90 divided by lambda, it's 520 nanometer, so it is 520 into 10 raised to minus 9. So the answer that we get here is 7.3. We can consider it as 7.5. So 7.5 on the top and 7.5 on the bottom side, the total central maxima are going to be 15 in number. So from the central maxima, the nth order is on one side of the central maxima, which comes 7.3, approximately 7.5, and on the bottom side we are going to get equal order of maxima. So 7.5 on the above side of central maxima and 7.5 below the central maxima. The total bright fringes that we are going to get is 50. We will move to the next question. Question says the light is replaced with red light of single frequency. State whether the frequency of the red light is greater than, less than, or the same as the frequency of original light. We know that in the visible spectrum, red light has the highest frequency. Red light has the highest wavelength. Since red has highest wavelength, the frequency of red light is going to be lesser. So we will write lesser frequency. The next question says, state and explain the effect of this change on the number of bright fringes formed on the screen. A calculation is not required. We know that frequency is inversely proportional to wavelength. If the frequency is lesser, the wavelength is going to be greater. And for the number of fringes, we use formula d sin theta upon lambda. If lambda increases, then the number of maxima is going to be lesser. So longer wavelength of light, and since we know n is inversely proportional to lambda, there will be less number of bright fringes. We will go to the next question, question number 7. The question says a particle Q and particle R are each composed of one quark and one anti-quark. State the name of the class of the particles that include Q and R. So we know that the certain type of particles which are made up of one quark and one anti-quark, they fall under group mesons. So we can write they belong to mesons group. Next question. Q has a charge of -1 electron where E is the elementary charge. R has the charge 0. Complete table 7.1 to show a possible second quark in each Q and R. Now see, Q is having resultant charge of -1 electron. Now talking about the strange quark has a charge of -1/3. So to have the net charge of 1 electron, the strange quark, let's say, adds with X. So X will be 1 plus 1 divided by 3 . It is -2/3. So we need to write about a quark which is having charge -2/3. So the answer will be antitop, because antitop has charge -2/3. Now talking about R, the net charge on R is 0 and the first quark in it is anti-up. So the second quark can be exact opposite of this quark. We can write it as up quark, because up quark plus anti-up quark will give us resultant charge 0. That sums up our paper 22 for May-June series 2024. Stay tuned on our channel for the further papers of AS and A levels physics. Thank you.